go through the different aspects that what we are talking about. In the first chapter, we are introducing what are the different materials and systems that are there and why do you need strengthening, and followed up with, examples of pictures where the different applications. Then the chapter 2 talks about scope of the guidelines itself, and any technology that you use, it will have limitations. So we are not saying that you use FRP to solve all the problem, but FRP has limits in terms of how much strengthening that you can increase. So all the limitations have been explained in this chapter 2. And then we are going to talk in chapter 3 provides detailed information on what is an externally bonded system, what is a pre-cured laminate, how do you put externally bonded system along with a near surface mounting system, what we call as a hybrid system. In fact, even the existing international codes, they don't talk about it. And in India, architects, they love to have sleek columns, and nowadays there is a tendency to have very long rectilinear columns. If you just wrap with FRP, it doesn't work. So for that kind of columns, if you want to improve the strengthening, you need to go for hybrid system. So we have talked about that. Yeah. You can, refer to the book. I don't want to get into the details, in the interest of the time. What are the different systems? With schematics, we have tried to explain, how do you do it? And similarly, pre-stressing, how do you do it? As Harsa said, if the structure has problem in terms of deflection, the only way you can recover the deflection is by putting pre-stressing. So active form of strengthening, and some pictures. And this is what I talked about. Hybrid FRP strengthening, which is one of its kind, I would say. We have also given a detailed example how you can actually use this hybrid FRP system for strengthening. And this is what, again, the deck overlay can be put in terms of whether high performance concrete or ultra high performance concrete. And at the bottom on the tension side, you can strengthen with CFRP laminate. So multiple combinations are possible. So this is the crux of the guideline. We want to make sure that nowadays people are using it willy-nilly, as Dr. Harsha said, but we need to test the raw materials carefully. Unless you test the raw material carefully, you cannot really guarantee the strengthening. So we have put a lot of stringent limits, and we are explaining what should be the minimum properties for fibers, what should be the minimum properties for pre-cured laminates, and what should be the minimum property if I make a coupon out of a hand layer process with fabric. All these things in line with international practice. It's also based on 15 years of research that we have done at IIT Hyderabad, also at IIT Bombay. So we have taken, and the chapter 4 talks about analysis and design requirement. As I told you, there is always strengthening limit, and we use strain compatibility, but what are the assumptions that you need to make? All those things are explained. And anchoring also becomes important. We want to avoid the debonding failure. So what kind of anchors we need to put, all these things are explained in this. And then hybrid system, as I told you, this is the wall type columns. In wall type columns, if I just wrap it, it just doesn't work. So we need to go for hybrid systems like this. Then you can increase the strength. And nowadays this type of wall type columns are becoming more and more common in India, fortunately or unfortunately. But then if you want to improve the performance, the only way we can do it is go for this hybrid system. And shear, again, shear is very important, shear and torsion. And we are using a lot of box girders that can undergo failure in shear and torsion. So how do you do that? All these things have been explained in this chapter 7. And again, for shear, anchoring is also important. When you have this kind of I-shaped girder, you have potential places of stress concentrations where your flanges are getting transformed to web. So what kind of grinding, rounding radius that we need to make, all those things we have explained very clearly with examples. Then seismic is a big thing. How do you do it? If you confine the concrete, you improve the moment rotation response, then you improve the ductility significantly. So how do you do it? All these things are given. And this is, I would say, is one of the, I think we spent a lot of time. We brought in various stakeholders, including the suppliers, the applicators and the designers, we took all their inputs and we are putting some stringent conditions, how do you make sure that the FRP is going to bond well with the concrete substrate. So all these things have been laid out, and you can see, how do you simple test, if I just use a hammer test from the sound that what it gives, we can tell whether the bonding is good or not. So all these things, again, the rounding radius that I talked about, the chamfering, what should be the minimum chamfering that we need to have. All these things have been given. And then Annexure A gives you worked out examples for various scenarios. That's what I said. Example 7 talks about hybrid FRP system, where even internationally we don't have any information on that. This is all based on extensive experimental work that we have done at IIT Hyderabad. And case studies, as Harsha was mentioning, the Cheru Bridge, so many, bridges we have already strengthened. So we want to learn from that, and we want to tell to the design engineers how it is being done in the field. So we have selected very good case studies, and then we are putting. And then how do you ensure the quality control after the installation? So we have a simple pull-off test. So you just put a dolly and create an opening around the dolly, and then you pull on it. If the failure is happening on the substrate, that means the quality of the bond is good. So this kind of such simple tests that we are given. Fire resistance, again, FRP, the weak link is a fire resistance. So you need to put increase of fire resistance. You can do it by putting some vermiculite bonding or some kind of applying insulation. So how do you do it? All these things have been given here. This is again, most of the manufacturers and applicators may not like it, but we are making sure that you need to test some components if you're executing a big project, right? So we are making sure that as a system, FRP is going to work well. So it doesn't mean that only a good fiber or good resin, but as a whole system, they should be compatible. So we are mandating, in fact, some component level testing to ensure that these products should be qualified. So this, in fact, we have a lot of resistance from the applicators, but I think the committee prevailed and said, because, every 10 years you cannot keep strengthening. So if you strengthen the bridge, at least 20-25 years of service should be guaranteed. So we have taken a very bold decisions in this document, and these are some samples, what should be the minimum length of sample that you need to test it for flexure, shear, and just briefly I'll talk about some of the works that, again, the testing is important, the raw material. Nowadays, what happens is carbon fibers are getting imported. Unless you know what kind of quality of the carbon fiber that you're using, then you will not get the strength. So yeah, and these are the carbon fibers are, typically 8 micron in size. It's roughly about 1/10 of your human hair. So it's how thin that fiber is. So testing is also very challenging. You need to have a good setup to do that. And you need to have this type of brooming type of failure, and then it's a good failure. So it's a sample, nowadays again, they are using 5 mm laminate. Sometimes the manufacturers, to push their product, what happens is they put in tender specification that you need to have a high thick laminate. In fact, high thick laminate is not really warranted. So by putting that, in fact, you may worsen the performance. So all these things are laid out, and these are some of the testing that we have done. The strength also, because it's a composite orthotropic material, you are depending upon the thickness, your strength properties also will change. So all these things we have laid out, and this is a unique setup that you have developed to test an individual toe. That's what Harsha was telling. We make a small needle, and you have to test this needle. That gives an idea how good your quality of fibers. Otherwise, people are using recycled fibers which are available, and this is, we are talking about a bridge, and people are traveling, and we don't want to have any untoward incidents. So we want to make sure that these fibers are also qualified very well, right? So, and these are some of the testing, and let me not get into it. And we also took extensive full-scale study, looking at these wall type columns, how actually the performance of the system is. So we looked at the shape, size, because bridge columns are usually 1 meter, 2 meter, and sometimes they are also wall type columns. So, people think that if I wrap with some layers, I get strength improvement. It doesn't work so. For small size columns, circular columns, it works very well. The moment it becomes more rectilinear, the confinement doesn't work. So in that case, I have to go for hybrid FRP system. And this has been proven experimentally. It has been published published in reputed international journals. It has been vetted by international community, and we have given improved confinement models in this guideline so that we are not going to make many mistakes and we can safely, strengthen this. Again, let me not get into the, the other details in the interest of time. So you can look at some of our research work that has done extensively. We have published in international journals, slender columns, and then the wall type columns, as I said, you can also combine with stainless steel plate, and then, you can wrap it up, and then what are the effect of these anchors? Again, the anchors, the improvement, the confinement efficiency can go up if I properly choose the anchor configurations. Again, this is one of the largest facility in the country. We can go up to 12,000 kilonewton capacity, large size columns. So we have really tested large size columns, which is also, the data is very, very limited. So in that say, I would say, this is a step in the right direction, I would say. This is again hybrid system where you put UHPC overlay on the top and FRP on the bottom. And I can go strength increase as high as 100%, right? So you can see these are testing done in flexure, these are testing done in shear. We are finding that the strength can increase as high as 168 and about 200%. So if you use the correct technology, you can really strengthen the deficient bridges, so without really demolishing it or building a new one. So these are all some pictures. Finally, it is the teamwork, as Harsha said. We would like to thank all the members for this is actually a work of about 10 years of our research and then 2 years of continuous meetings. So we have taken also inputs from international experts like Thomas Lipinski, Yuri from Russia. So in that way, we are really proud of our effort. I would like to thank our convener, Dr. Harshavardhan, for leading the effort, and also all the various stakeholders involved. I feel that this is a great contribution, and also I can say that this is one of the quickest document that we were able to do it in 1.5 years, which is in the history of IRC, probably it would have been one of the quickest. Harsha would not disagree, hopefully. So with that, thank you for your kind attention. So